Hello, PascoMath grade 6 teachers. Today we're going to look at 6.EE.1.2. We're going to unpack the standard, look at some things you could be doing in the classroom as well as some things students could be doing, and then look at some misconceptions and come up with some strategies for you to address those misconceptions. So let's go ahead and get started. The standard itself is pretty lengthy. It says write, read, and evaluate expressions of which letters stand for numbers. And so then there's three subcategories there. So they need to write expressions that record operations with numbers and with letters standing for numbers. So their example straight from the standard is subtract y from 5 as 5 minus y. They also have to identify parts of an expression using mathematical terms. So this is very much mathematically with the vocab rich standard. So our sum, term, product, factor, quotient, coefficient, a lot of things going on. View one or more parts of an expression as a single entity and describe the expression. So like 2 times the quantity of 8 plus 7 as a product of two factors. They view that 8 plus 7 as a single entity and the sum of two terms. They also have to evaluate expressions at specific values for their variables. So that would be when they use substitution. Include expressions that arise from formulas used in real-world problems. They also have to perform arithmetic operations, including those involving whole number exponents in the conventional order where there's no parentheses. So this is where we really get the order of operations there. And then, for example, even in they have the formula v equals s cubed, a equals 6x squared. Find the volume and surface area of a cube with a side length of a half. So unpacking the standard. So parts A through C of the standard emphasize translating expressions from verbal expressions to numerical expressions, and from numerical expressions to verbal expressions. And so that's a tough thing for students to do. Math is definitely just like any other language, they need to learn it. And so this is where we need a lot of emphasis that precise math vocabulary. Students evaluate expressions for given values with variables and examples, such like in part C. And then students identify parts of the algebraic expression, including sum, term, product, factor, quotient, coefficients, and constants. So some things you can be doing for the classroom. You can explore with students that letters called variables represent unknowns. And the same rules apply in operations with numbers, also apply with those operations with variables. So also provide opportunities for students to translate verbal expressions into numerical expressions and vice versa. So they need a lot of opportunities to go back and forth there. You need a model. The notation of 6n is 6 times n because a number and a variable written together means to multiply. That's something that's not just intuitive, it needs to be explicitly put out there. And then help students define the parts of an algebraic expression, including variables, coefficients, constants, and the names of the operations. And again, just that repeated modeling of you as a teacher of using that precise math vocabulary and then demanding that from the students. And so terms, the values in the expression separated by addition, subtraction. You got multiplication and division in expression represent that single term. And the coefficients, that number that multiplies by a variable, such as 4 is the coefficient of 4y. So some other things is provide practice and opportunities where students need to identify parts of an expression. So 3x minus 7, where 3x is the first term, the coefficient of the variable x is 3. So again, that precise math language is important. The second term is 7, and it's a constant. Provide opportunities where students evaluate algebraic expressions for a given value of the variable. So then we can go up, what is the value of the expression 3x minus 7 when x equals 6? And they would have to know the substitute in 6, 3 times 6 minus 7. Focus that attention again, I think I've said 3 times at this point, so why not go for a fourth, on that vocabulary. So algebraic expressions, evaluate, sum, term, product, factor, quantity, quotient, coefficient, constant, like terms, equivalent expressions, variable. Very, very vocabulary rich standard here. So let's look at things that the students should be doing. They need to recognize that variables represent unknown quantities. Translate verbal expressions into numerical expressions and numerical expressions into verbal expressions. Communicate orally and in writing about translating and evaluating expressions used in precise math language. And evaluate expressions for given values of variables using the order of operations when appropriate. So when looking at some student misconceptions and how to address those, so a lot of students, not a lot, some students might incorrectly, they'll confuse x to the third and 3x. And so just like the table here explains, like we really just have them expanded out. So like what does x to the third mean, or x cubed? It means x is used as a factor 3 times. And so x times x times x, where 3 times x, or 3x, is just multiplication, and multiplication is repeated addition. So that's x plus x plus x. And that distinct difference between x uses a factor 3 times, x times x times x, versus x plus x plus x. Also, a lot of students will have difficulty translating verbal expressions to numeric expressions for sure, or algebraic expressions for sure. And just the problem I listed right here is like a great one to ask students. There are 6 times as many boys as girls. And so when you ask this, just pose it to the class and have them write down their algebraic expression. Some will write, for sure, they'll do 6 times as many boys as girls. And then some students might write 6 G equals. So when looking at some student misconceptions, how to address those, some students might misunderstand or incorrectly read the expressions. X to the third and 3x is a common one when they're confused the two. And just go back to, we just worked with 6.EE.1.1, and so with x to the third, like demand, like what does that mean? Like x is a base, 3 is the exponent, x is used as a factor 3 times. And then how is that different than 3x? Well, 3x is just 3 times x, and multiplication is just repeated addition. And so it's x plus x plus x, and there's a distinct difference there. And so just like the table shows, I'll definitely have those two, like a similarity difference thing going on in the classroom, and have them make sense of it. Also, when translating verbal expressions to algebraic expressions, um, again, I said students, it's a really tough concept for students to grasp. And so if you just pose that question that I have there, translate this verbal expression to algebraic. There are 6 times as many boys as girls. I guarantee in your class you'll have this. And some might write that boys equals. And so you'll have those two out there as two different representations. And so although there is a misconception, I think this is awesome because now we get to talk about it and we get to address it before the assessment, right? And so use that misconception or error like for learning. And so here I would just pose a question, like, first, people that say 6b equals g definitely have an opinion. Students that say b equals 6g definitely have an opinion. Have them try to convince each other. Have a little math argument about it. Math practice 3. Also, I'd have them, just some questions you can probe. Do we anticipate more boys or girls? So if there are 6 times as many boys as girls, we definitely anticipate more boys than girls, and then have them act it out, like, or even pictorially draw it out. And so, that 1 to 6 ratio, if we have 1 girl, how many boys do we expect? We expect 6 because there's 6 times as many. If we have 2 girls, how many boys do we expect? We expect 12 because there's 6 times as many. So the 6 times the 2 girls equals 12 boys. And so they know how to substitute. We've done that already in the standard. And so even have them substitute values there. And so again, act out, substitute until they see that that is the correct expression there, because we need to have more boys than girls. And so if there's 1 girl, 1 times 6 is 6 boys, and that ratio holds true. That's it for this standard. If you have any questions, feel free to contact me or your regional specialist, and thank you for making PascoMath more awesome.